Hello and welcome back to Bedroom Producing with Chris Porro. I'm Chris Porro. Today I want to talk about null tests. What is a null test? Why is it useful? What cool null test hacks can help you verify things about audio? What cool stuff can you do with a null test? So a null test, to start off as an overview, is a way to compare two pieces of audio and see if they're exact copies of each other, or if they're not exact copies, to hear the differences between the two. So what cool stuff could you do with it? You could compare a cheap plugin with an expensive one to see if you should actually pony up for the expensive plugin, or to see if there's some magic in that expensive plugin, or if there's no magic at all. You could compare two files that you suspect are the same file, maybe they're labeled differently, and figure out if they are exact copies of each other. You could compare, for example, a WAV file and an MP3, or a 16-bit file and a 24-bit file. Any type of processing you could do on a file, you could listen to the difference before and after. Which is really handy. So first I'm going to describe, I'm going to show you kind of like practically what a null test is. So it's kind of like, if you don't know what a null test is or you're confused about it, I'll show you how it works, a simple example of that. And then we'll go into each of these things case by case, and I'll show you how you would use a null test to do the things that I just mentioned a second ago. To start off with, let's say I have a file here. If it's not a file, it's an audio clip. It's a clip of audio. And this is just a simple sine wave, right? Now, if I take this clip and I make a copy of it and I bring it down here, and so now we've got the exact same piece of audio on two different tracks. Notice that the volumes are the same, the processing is the same. You can see there's no processing on here. You have to take my word for it if you're not familiar with Reaper. But basically the volumes are the same, the processing is the same, and everything. Now, if you play this first one, you'll hear the sine wave. And if you play the second one, it'll just sound like the same thing except louder. And I'll add it in. And take it out, add it in, right? So what's happening, because these are copies, is one copy is kind of like being added on top of the other one, and the effect is the same as moving the volume fader up on this, like 6 dB. It's a 6 dB increase in volume. Okay, so really not a lot of surprises there. What is surprising is that if you invert one of these tracks, in other words, you put this out of phase, like 180 degrees, I think it's 180 degrees out of phase. Let's see what happens. So this is a little invert button. This is where it is in Reaper, but a lot of these DAWs, you know, any decent DAW is going to have a way to invert a track. And I'm going to talk a little bit about what inverting means in a second, but let's just listen to this. And now let's invert it. So what just happened is we completely canceled out. These two tracks completely canceled each other out. That's how you know they're exactly the same. If one of them was slightly different, you wouldn't have absolute silence. And if you look over here on this pre-master, but for all intents and purposes, this is our master track, you'll see that there's nothing on it, right? Now, the way that this works is, let's take a look here. The way I've got this displayed right now, we've got this x-axis, which is running through this waveform, right? This waveform here. And all of the waveform on this side, these guys up here, those are positive values, and these are negative values. And this is what they call the zero crossing. So you could also think of this as compression waves in the air. This is kind of like a section of compressed air, and this is kind of the opposite of it. You know, like this top part is compressed air, and this bottom part is kind of expanded air, And this right here is neutral. That's like no sound. So when you hit this invert, what happens is it takes this copy, right? Because that's this track. It takes this copy and it flips it. So instead of this being a peak, it's a trough down here. Instead of this being a trough, it's a peak, right? Another way to look at that is to say that it's multiplying all of these values by -1. So if this was 100 at the peak and this was -100 at the trough, this 100, once multiplied by -1, becomes -100, so it becomes a trough, and this trough becomes a peak because it's -100, and -100 times -1 is 100. So basically, it flips this. And when you flip it, and these get summed together, that's what the master bus does. It sums the math together. They perfectly cancel out. Now, right now, even though this is inverted on the track, it's not visually showing you this as being inverted. So let me show you something else here. If we could find a way up in here to invert the phase of this item, now this is flipped. So again, when this summing is happening, it's going sample by sample, sample along as this playback head moves, right? It's going sample by sample. It's getting the amplitude from this wave and this wave. It's summing them together, and it's outputting them to this master, right? And since we just inverted this bottom item here, we will also get a complete cancellation, right? So it's completely canceled. Now, let's look at this with a piece of real audio, because I don't know if it's apparent, but let's see. I don't know if it's apparent, but this also works on, it doesn't matter how complex the waveform is. And here's something that's a lot more complex. So let's zoom out. Same thing. We have let me play this. Sorry about that. Let me play this. We'll play the copy of it. And now we'll invert it. Okay, so you can see the levels are still, the track meters are still catching the levels, but after they get summed over here, they null each other out. They cancel each other out. Another way to talk about this would be called a cancellation test, I suppose. All right, now let's look at the cool stuff you can do here. I'll start off with the absolute coolest and work my way back. So we'll start with the lead story. There's a lot of talk online about, oh, this plugin does magic. Oh, that's a cheap stock plugin. That doesn't work. You have to spend more money on it, or, it doesn't sound as good. So one test that I ran years ago is I took two EQs. One was a UAD vintage EQ, the Universal Audio stuff. And one was just my stock Reaper EQ. And basically I found out that if I ran kind of a null test comparison. In other words, I have a chunk of audio on one track and the exact same chunk on the other track. And on one track, I had the Reaper stock EQ, and on the other track, I had the really nice EQ, right? And I wanted to see if I could get them to null out, because if you get them to null, what you know is that this expensive EQ is performing the same way as this cheap EQ, right? The idea being if both of these are exactly the same, they'll perfectly null out. So hopefully you're following me on that. So what I decided to do is try to compare, this is a recent version of it, where I'm trying to compare the Ozone mastering EQ with a stock Reaper EQ. What I did is I put the Reaper EQ on. I matched all the parameters. So the center frequency, I think I picked 5,000 for this. Oh, sorry, I already picked it. It's over here. Center frequency of 5K, reduction of 6 decibels, and a bandwidth. Now, here's one thing that's confusing. So initially I had a bandwidth of 2, and then I came over here to the ozone plugin, and I have a Q of 2. Now bandwidth and Q both kind of measure the same thing. It's the wideness. For example, if you watch this up here and you change the bandwidth, you can see that it's changing the kind of width of that bell, right? This is a very precise EQ cut, and this is one that's more spread out over several octaves. So, but bandwidth and Q are not the same, so you cannot use 2 bandwidth and a 2 Q to compare these two. So that's why I went over to this handy thing that hopefully I can find now. All right, so I'm going to come over here, and I'm going to try to find out what this Q of 2 would be over here on this bandwidth. So Q of 2, and calculate 0.714. You know what? Let's just cut and paste this out. Okay. So hopefully this is making sense. Well, first let's verify that this doesn't actually null. Okay. I'll play it, and then I'll invert this one. Okay. So you can see, obviously we can hear something, but also there's a pretty decent level here, like a peak at -24. So obviously this is not nulling out all that well. Now let's play with this as we're listening. This is another trick for when you're doing a null test. Play with parameters, and when the null is going really well, you'll hear more and more cancellation. Things will get quieter and quieter. So let's try this. Now we know that this is going to be a lower value, so let's just, and basically watch the master fader levels over here as I approach where this is supposed to be. It's supposed to be down at, I think, 0.7. Okay, we got really quiet. I can't hear anything. Now let's see if we can paste in that very precise level. And that's really no better. So, but what I'll say is, although it's not a perfect null, it is so incredibly close. I can't hear anything. You're not going to hear this in a mix. You're not going to hear this. You're not going to hear this processing. So for all intents and purposes, here's a free stock plugin with really low CPU usage that's doing exactly the same as this ozone plugin, which is interesting, right? I mean, I'm a type of person who likes to verify stuff and not listen to forums. So that's about the coolest thing that I can think of you can do with a null test. Let's look at some of the other things you can do. Now here we have a wave and an MP3. You ever wonder what the difference between a wave and an MP3 really is? This is a 128 megabits per second MP3, which is a very common MP3. And here we have the original wave file. So let's listen to them back to back and just see if we can hear any differences. Okay, I've done this before. I can tell you I can hear just about nothing. Maybe if I sat here for a half an hour and I used some of my tricks for listening, maybe I could hear a difference. But right now I'm hearing just about nothing. But what is the actual difference between these two? Well, you can use a null test to figure that out. So let's play them both and we'll just invert this. We'll see if it nulls to 0 or how close it gets. Yeah, quite a bit of a difference. But it's interesting that I'm not even sure I can perceive this information when it's taken out in the MP3, because this is the difference between the MP3 and the wave. Obviously, the wave has more information. So what you're looking at here is what is removed from the wave. But whatever they took out, very hard to perceive. So in practical terms, this MP3 sounds really good. Just about nobody, I think, is going to notice this. Maybe a mastering engineer that's in a pristine monitoring environment. What about if you get two files and you're like, geez, I are these the same, or did somebody print some effects to it? Did they put some EQ on it? Did they drop the level? Is there some distortion on it? And you wanted to find out, are these two files the same? Well, I printed some, I'll move this over here. I printed some EQ on here, on this one that says printed EQ. And basically I rolled off everything. I did a high pass at 100 Hertz. So all the really low end is gone from this file. So again, let's just listen to these two. Let's just listen to these two. And what I like to do is this little trick here where I just can toggle one button. Now, part of it is there might not be a whole lot of low-end content in this particular track. This would probably be a lot more recognizable with a bass or a kick, but I can barely hear anything. If I listen really closely, I think I can get this right most of the time. But let's see what was actually taken out. Let's see what the difference is between these two. I mean, again, that's really significant right there. I mean, you can hear it. And it's got a, oh, sorry, that was not a peak of -12. That was just the clip that happens when you don't have a fade at the end. But quite a bit got taken out, and I can't hear it. So, again, I think a null test is a really practical way to do like a sanity check. Are those files that different? Is that fancy EQ that much better? Do I have 15 copies of the same file and I don't need them? Or this file that you got back from somebody, is it what you gave them? Is it the original? So it's a good way to like verify things. And I'm a big fan of like first person experience of verification. So there it is, null files, how to use them, how they can be useful, how you can verify things for yourself. Trust your ears, verify for yourself. And I think that's a wrap.